Today, me and my group will be presenting the Mail Matcher. It is a remote mail sorting device.
Hi, my name is Jacob Burned, and I'll be attending the University of Rochester for civil engineering this upcoming fall. I've been with the POTW course track since freshman year, and I'm also the president and founder of Coding Club, and have twice thus far competed in competition at the Siena Coding Competition. I'll be running track as well as cross country for University of Rochester come fall.
Hi, my name is Lucas Gall, and I'll be attending Rensselaer Polytechnic Institute and majoring in civil engineering. I've taken 6 Project Lead the Way courses during my time at Saratoga Springs High School. These courses made me use computer-aided design, which improved my skills, whether that be on Inventor, Revit, or Fusion.
Hello, my name is Jonathan Panarese, and I will be attending St. Olaf College to study economics with a business minor. In addition to attending academically, I will also be playing D3 college baseball. I am a student who likes to be in problem-solving situations like STEM classes, for example, math, sciences, and engineering. I have been enrolled in the PLTW courses for 5 years and wanted to take this final class, which is Engineering Design and Development, to get a better understanding of what engineering is like in the real world. Today, we would like to present what the problem is, why is this a problem, what current inventions combat this problem, how we can solve this issue, and what our next steps will be. Our problem statement. We concluded that over 300 million residents in the United States receive junk mail that must be sorted. We also found that over 55% of total mail volume is junk, and this has been the same since 2015. We have found as a group from watching family, friends, and small business owners that sorting mail takes around 10 to 30 minutes, which takes time away from productive endeavors and different uses of time.
Now that our issue has been determined, our process will relatively follow the design process. We'll be gathering information in the form of patents as well as target audience. This will be surveys, talking to experts. From there, with our given information, we'll go about brainstorming, trying to come up with our own ideas, jotting down and drawing mostly as many possible solutions as we can think of. With these concepts, we'll come up with different iterations of them, further expanding until eventually we settle on a final solution in which we'll refine and make as efficient as possible our end design. We'll construct a prototype. This will be in the form of CAD model fusion using laser cut wood due to its accessibility and ease to put together. We'll test our prototype, and from our test, we'll examine the data that we've gathered, figured out what can be improved and what went wrong, revise and remake the prototype.
We tried to contact well-known businesses to see if our mail match sorting system would be something of interest in the business world. We contacted Staples, Best Buy, USPS, and our Saratoga Springs High School front office. We did not receive responses from the major companies, but our Saratoga front office stated that this would not be a useful product in the school setting. This directed our attention to the fact that this product may not be useful in large commercial settings, but this might be a good product at the consumer level. We conducted a survey that was 7 days that had 32 respondents. We asked some basic questions like how old are you, how much of your mail is junk, and how much time to sort the junk mail per week. We took this along with the survey responses and helped figure out a way our target market could be most useful for the product. After considering the survey results, we determined that our target market would be a residence by the age 30 and up with an income level of minimum wage. In this product, we could sell all over the nation for different homes.
Here we have some examples of existing technologies that have patents, although they may or may not have actually been made. This patent features a mailbox that would be equipped with a sensor and a scanner that will then scan the mail, upload it to a computer, and then that computer would send you a scanned copy of the mail in the mailbox. The issue with this is that the patent doesn't actually sort the mail, and there's no way to sort the mail from your phone until you have to come home and do it manually. This is the flowchart of another patent that shows how mail is sorted in an industrial setting. This is very similar to how mail is sorted before getting sent to each recipient. The issue with this patent, of course, is the fact that using technologies like this in a small home scale would be obsolete and expensive in order to sort junk mail. This is our decision matrix of the ideas that we brainstormed after looking at existing technologies. These ideas were ranked based off of durability of the build, how complex it would be to manufacture, ease of use for the consumer, efficiency at sorting mail, as well as cost to the consumer. Each idea we designed are as follows. The table sorter. a tabletop mail sorter that will scan mail and use keywords to automatically put pieces of mail into junk mail and a non-junk mail pile. The hand recycler, an indoor machine that will recycle your junk mail into fresh paper. The mail swipe, an outdoor machine that will scan mail and send it to your phone. You will then be able to connect remotely to it and sort the mail from anywhere. The mailbox sorter, an outdoor sorter that scans mail for keywords and sorts them automatically into a junk or non-junk pile. Then the auto recycler is the mailbox sorter, but composts the junk mail instead of putting it into another pile. Lastly, the phone scanner is an app on your phone that you can scan mail and it will use keywords to tell you which pieces of mail are junk or not. This was obviously not our brightest idea. Each idea on the matrix was scored from a value of 0 to 5, 5 being the best, 0 being the worst. After combining a point total for each idea, we decided that the mail swipe was going to be the best idea, and we would pursue it.
Considering the Postmaster General's seal of approval, we had to take into account what was required for a mailbox. As shown on the PowerPoint, for a mailbox to be recognized by the USPS, it needs to follow the standards and regulations in order to receive mail. All new or custom mailbox plans need to be approved by the local postmaster to receive this mail.
Given our design being the mail swipe, we settled on a set process that the mail swipe would undergo, and we would revolve our future designs around this process as we believed it was the most efficient way to sort junk mail. The mail would be put into the mailbox. In this case, it's going to be the mail sorter, so shaped a little differently. In this first compartment that the mail is in, a conveyor will be lowered and it will be pushed up and into a third compartment sitting on top of another conveyor where a camera will take a picture of the mail, send that picture to your phone, and the mail will then be moved into a third holding compartment where it will stay until you decide to open your phone, decide yes or no. From there, the mail will be moved and determined by a flip-flop motor whether or not it's going to go into the junk box or the keep box, where it will wait until a person comes to pick up.
After using our design matrix, creating our flowchart, and doing some final brainstorming, these were our final designs. We ended up using Jacob's design, but we are opting to use conveyor belts to move mail around instead of mail sweeps as pictured in the drawing. This is to ensure that when a stack of mail is put in, we can take one piece of mail off from the top and leave the rest of the stack there, as the piece of mail is being processed through our machine. This was our first fusion model. It was actually pictured in our last presentation that we did, and our issues with it is that it was too big and wasted too much material. So instead, with our new design, we opted in to cut the bottom off and we shrunk the sides in a little bit more. This way it made the mail sorter not take up as much material, but it also made it way sturdier by having those 2x4s in the bottom.
This is our prototype based off our final fusion model. We had to use supplies found around the classroom, and we used plywood cut with a laser cutter. The hardware was found around the room and also different hardware stores and online stores. The prototype is not completely finished, but you can see the finished product in the fusion model from the last slide. We completed the conveyor belt in order to test how it would move different pieces of mail.
Our method of making the motors run and the hardware that'll go into our mail swipe came in the form of Raspberry Pi because it was the simplest option to base our hardware around. Coding in GPIO, Raspberry's software, was relatively simple to work the 6 motors and camera that were required to accomplish each task when prompted. These tasks had previously been stated in the flowchart. The Raspberry Pi would be connected to the L298 motor driver, which would allow the Raspberry Pi to send pulses to the motor driver to then be relayed to our motor, being powered by an external source. Ultimately, we decided to make an improvement to our hardware with the inclusion of a PIR, a passive infrared sensor. Whereas before the camera was running continuously, waiting for mail to come into frame to then have a picture taken and sent to your phone, the sensor would more efficiently detect a change in the environment, in this case, mail being inserted, mail present, and trigger the mail sorting sequence. The Raspberry Pi software system was limited when it came to interactions with the sensor. So we decided to make the switch in which single board computer we were using from Raspberry Pi to Arduino. And this was necessary as the motor, the camera, and the sensor could be used in coherence with our chosen Arduino Mega single board computer.
This is our materials cost breakdown. The total cost of materials is around $500, and we would project our sale price to be around $600 for some room for profit. Now, this price does seem high because we use products around the room that would not necessarily go into the final product, like using the Raspberry Pi in the coding system. We would develop our own. Because of the large scale of this product, we would not sell this in a continual production, but we would sell it to order.
So because we couldn't finish our project, we did actually finish a conveyor belt, and what we did is we just pushed it down each piece of mail. We used a dual range force sensor with Logger Pro software to record the forces, and these were the measurements that we got. We wanted to compare to see if mass or area would change how the mail can be pushed, and we saw that area, it really didn't matter, it was going to get pushed, but the mass is what really mattered. And when we had the large catalog underneath the conveyor belt, it wouldn't budge. The motor was stopped, the force reader read 0.056 newtons, it wasn't budging. And although we couldn't test our actual project, like uploading to the phone, we were able to do this. One thing to note though is that if you push it on two pieces of mail, it actually does push the top piece of mail, and the stack of mail that's underneath stays.
Time was our biggest issue for this product because of how our schedules ran with 80-minute class blocks. It was hard to make big progressions during this little time when our momentum would be stopped. There was a lot of time in the planning and modeling phase to try and get this product aesthetically pleasing and in the most functional way. Our first model was too big and unrealistic, using way too many materials. Our second product was scaled down to try to use less materials in a most cost-effective way. Our conveyor belt we had to make from scratch, but due to time and the material constraints, it did not come out as well as we would have liked, but it is functional. Our coder Jacob Byrne used many resources like teachers, friends, and online sources to help him come up with a code that would move the conveyor. Even though this project took a lot of time and wasn't completely finished, Jacob used his time wisely in order to get what we needed done. Our project timeline, we started off on track, but when we got to the drawings and prototype testing, this is where we started to lose our progress and start to fall behind schedule. Each day we worked diligently to try to get as much done as we could.
Time management and simplicity would have been major factors in how a completed in full product could be produced, as we weren't able to complete all that we set out to do due to previously mentioned reasons. However, what we did get done, the conveyors, based on our tests, could have been made more effective and improved to move more mail within a wider range of different area densities via more power to the motor, an increase in quantity of motors per conveyor to increase the amount of weight that can be moved, or stronger motors. The current motors being smaller hobby motors that could only produce 28 watts of horsepower.
We will be ready and prepared for next Monday's Q&A, where we will address any questions you may have. Thanks for watching.